So system means the observing body or the considering body. We are talking about system. So system means the observing body or considering body. So let's suppose we have a system. See, actually system is user friendly. You have to make any type of system. You have to make any type of system according to your situation. System is basically, my dear student, in physics, for system there is no any rule. System means the body which will be followed by observer, or we can say the body which is observed by observer. I'll write here body which is considered by observer, first thing, and second thing is system can be taken by observer without following any rule. So see, my dear student, I am taking a system. In this system, let's suppose 3 particles are present. I am taking a system in which 3 particles are present. Let's suppose body first, body second, and body third is the part of my system. Body first, body second, and body third, let's suppose, is the part of my system. So in my system we have 3 particles, first particle, second particle, and third particle, my dear student. So in my system 3 particles are there. You will choose only 2 particles in your system. You will choose all the 4 particles in your system. You will choose only 1 particle in your system. Right, to understand what is internal force and what is external force. Basically, internal force and external force depends on what kind of system you are considering. So see, my dear student, this is our first body. In this body, all the particles are applying force. All the particles are applying force in first body, and this first body is present in system. So my dear student, this first body experiences force due to second as well, experiences force due to third body as well, and experiences force due to fourth body as well. I am repeating once again. This first particle experiences force due to second body, force due to third body, and force due to fourth body. Now see what actually internal force is and what actually external force is. The body which is experiences force is first. This body is present in system. I am repeating once again. This first body is present in system. This first body is experiencing force due to second, due to third, due to fourth. Now see what actually internal force is and what actually external force is. Those body which is experiencing force and the body which is applying force. I am repeating once again. The body which is experiencing force and the body which is applying force if both are present in system, then the force which is experiences by body is called internal force. Remember, my dear student, if the body which is experiencing force and the body which is applying force, if both the bodies are present in system, then the force which is applied by the body on other body, that force is considered to be, my dear student, internal force. See, actually F12, that is force on 1 due to 2. What it implies? It implies the force is acting on body 1 and applying by body 2. So the force which is acting on body is present in system, and that body is also the part of system which is applying the force. So this F12 is considered to be internal force, because the body which is applying force and the body which is experiencing force, both are present in our system. So F12 is said to be internal force. Let's move forward. F13. Now see, force on 1 due to 3, that is force is applied by 3 and experiences by 1. Now see, both the bodies, the body which is experiencing force and the body which is applying force, both the bodies are present in system. Hence we will say F13 is also called internal force, is also called internal force. I am repeating once again, if the body which is experiencing force and the body which is applying force, if both the bodies are present in system, then that force is said to be internal force. Moving forward, now see F14. So F14 means force on body first applied by fourth body. Now see, the body which is experiencing force is first, it is the part of system, but the body which is applying force, that body is fourth body, but this fourth body is not a part of system. Hence we can say F14 is an external force. So what is the definition of external force? The body, if the body which is applying force or the body which is experiencing force, any one of the body is present out of the system, or both the bodies are present out of the system, then that force is said to be external force. Then that force is said to be external force. Remember, very important concept is this. One is internal force and then another is external force. Internal means the body which is applying force and the body which is experiencing force. If both the bodies are present inside the system, then we can say the force is internal force. But if any one of the body, either experiencing or giving the force, is out of the system, then the force is said to be external force. I am writing once again the definition of external force. So write down, if the body which is experiencing force, if the body which is experiencing force, if the body which is experiencing force or the body which is applying force, or the body which is applying force, or the body which is applying force, if any one of the body or both bodies, if any one of the body or both bodies are out of the system, then the force which is experienced by body, then the force which is experienced by body, is called external force, is called external force. So my dear student, forces can be now categorized into two different situations. One is, my dear student, in one situation we'll explain the force by nature. It is of two types. One is conservative and second is non-conservative. Next category is internal force, and second is your external force. So one type of force is conservative force and another type of force is non-conservative force. One type of force is internal force and another type of force is external force. But one thing that you have to remember is, internal and external force, to make force as internal or external, it is in your hand. It is in your hand. Make a system, there is no any rule for making the system, hence we can say internal and external force, making force to be internal or external, this is on the hand of observer. But conservative and non-conservative, the nature of conservative and non-conservative is basically a basic nature of force. We cannot make any non-conservative force to be conservative force or conservative force to be non-conservative force. So remember one thing, internal and external force, making force to be internal or external, it is in our hand, but conservative and non-conservative forces is of by nature. We cannot change this. Like for example, friction is non-conservative force. We cannot make friction as conservative force. But in some case, if friction is external force, we want to make it internal, we can. Because internal and external force, to form internal external force, or we can say to make any force to be internal or external, it is up to observer. So please write it down in form of note. For making internal and external force, for making any force to be internal or external, for making any force to be internal or external, for making any force to be internal or external, it is on the hand of observer. It is on the hand of observer, but we cannot make forces to be conservative or non-conservative, but we cannot make forces to be conservative or non-conservative, because conservative and non-conservative properties, because conservative and non-conservative properties is basic nature of force, which cannot be changed, So remember one thing, my dear student, internal force, if any body is applying force and the body which is experiencing force, if both the bodies are present inside the system, then the force is considered to be internal force. And if any one of the body, either the body which is applying force or the body which is experiencing force, if both are present, if any one of the body or both are present outside the system, then the force is said to be external force. And we all aware with conservative and non-conservative force as well. If the body in round trip, if the force in round trip performs 0 work done, then it is conservative force. For non-zero work done, the force is non-conservative force. So moving forward, my dear student, write down energy. So energy is basically scalar quantity. There is no any direction of energy. First of all, we'll talk energy. So first thing about energy is, it is a scalar quantity which only have magnitude but not direction. Second thing about energy is, SI unit is joules. SI unit of energy is joules. So please write down. The energy is a scalar quantity. Please write down. Energy is a scalar quantity which only depends on magnitude, but not direction. Second thing, write down. SI unit of energy is joule. SI unit of energy is joule. Now see my dear student, basically energy is of two types. First is your kinetic energy and second is your potential energy. First is kinetic energy and second is potential energy. And if you'll add both the energy, means kinetic energy plus potential energy, you'll get a new form of energy which is also called mechanical energy, or we can say total energy. So basically mechanical energy and total energy not is a part of energy. Energy only is of two types. One is kinetic energy and second is potential energy. And if we'll add both energy, that is kinetic energy and potential energy, then we'll get a new form of energy called mechanical energy or total energy. So please write down my dear student, energy is of two types. Energy is of two types. First kinetic energy and second potential energy. First is kinetic energy and second is potential energy. Now if we'll add both the energies as kinetic energy plus potential energy, adding both the energy, kinetic energy plus potential energy, will get a new form of energy. But remember, this is not a type of energy. This is not a type of energy. If anyone asks how many types of energies are there, I'll say only two types of energies are there. One is potential energy and another is kinetic energy. If we'll add both energy, that is kinetic plus potential, we'll get a new form of energy called mechanical energy, or we can say total energy. But mechanical energy or we can say total energy is not a part of energy. So remember, one is kinetic, another is potential. Total energy is basically kinetic plus potential, or total energy is also called mechanical energy. Now we'll discuss energy by turn. So please write it down. First we'll discuss about kinetic energy. We'll discuss about kinetic energy. So basically kinetic energy is that energy due to which body is in motion. See, actually if we are performing work or we are moving, we need some energy. So that energy which need for motion is called, my dear student, kinetic energy. Remember, the energy which is required for performing motion, or we can say the energy by virtue of which the body performs motion, is called kinetic energy. So please write down the definition of kinetic energy. Write down the definition of kinetic energy. So write down the energy by virtue of which the energy by virtue of which the energy by virtue of which body performs motion, the energy by virtue of which body performs motion, the energy by virtue of which body performs motion is called kinetic energy. See, my dear student, if any body is in motion, remember that motion is basically due to kinetic energy. Kinetic energy is basically motional energy. If we want to perform motion, then we need kinetic energy. Remember this thing. That's why we'll write the energy by virtue of which body performs motion is called kinetic energy. Now we'll discuss next point. Please write down. Please write it down. The amount of work done. The amount of work done. The amount of work done is defined by force. Is defined by force. Now we have to find the relation of, my dear student, kinetic energy. If we all are aware, but still we have to find We all are aware the relation of kinetic energy is nothing but half mv square. We all are aware, but still we'll find the relation of kinetic energy. So see my dear student, let's suppose we have a body and this body is moving from point A to point B. Let the displacement between point A and point B is S. Due to the force, let's suppose the mass of body is m. Due to this force, the body starts performing motion and it moves from A to B. So A to B direction is basically direction of motion. Now let's suppose the body initially at rest, and after applying force, or we can say after experiencing force, the body starts moving with velocity v. So I am writing here, let the initial velocity of particle be u, which is equals to, my dear student, 0, and final velocity of particle is considered to be v. Now I am applying equation of motion. So by equation of motion, we can say v square minus u square is equals to 2as. So v square minus 0 square is equals to 2as. So a becomes equals to v square by 2s. This is the value of acceleration, and we all know that if force is there, then body must carry acceleration. That's why I'll get the result of acceleration. Now by Newton's laws of motion, we can write F is equals to ma. So instead of a, we can write v square by 2s, m into v square by 2s. Now this is basically force. If we know that force is there, displacement is there, so work done by the force. I am writing here work done by the force. So work done is nothing but force into displacement. So work done is, the value of force is mv square by 2s into displacement is s. See, s and s get cancelled. So work done is equals to half mv square. My dear student, this is the value of work done we'll get. Now see, the SI unit of work done is joule. SI unit of work done is joule, and SI unit of kinetic energy, SI unit of kinetic energy is also joules. So in physics, my dear student, we are free to replace the two quantities if their SI units are same. So see, my dear student, the SI unit of work done is joule, the SI unit of kinetic energy is also joule. So basically what happened, we will replace work done by kinetic energy, because both the terms carry same SI unit. So if same SI unit are there, then we'll replace the terms. In physics, you are free to replace the terms if two quantities have same SI unit. So if work done, the SI unit of work done is joule and the SI unit of kinetic energy is also joule, so replace work done by kinetic energy. So we can write kinetic energy is equals to half mv square. This is the relation of, my dear student, kinetic energy if the body is moving under the action of a force F. So this is all about relation of kinetic energy, that is half mv square. I hope you all understand what actually relation of kinetic energy is. So my dear student, in next class we'll discuss some more topics. Till then, please make proper notes so that your memory, you'll revise your chapter properly, and please try to solve the numericals. Of different forms, so that in physics you will experiences good, or your marks you have very good base. So thank you so much. Till then, my dear student, we'll discuss next topic in next class. In next class we'll discuss some numericals as well as topic. So till then, please take care, stay safe. Work, power, energy, remember, is very important chapter. Please go ahead properly We'll meet in next class. So thank you so much dear student. Take care.